I actually started off in fundamental particle physics, so working at CERN in Geneva. Um, and that was really exciting. I love the research environment, I love the work, but most people who work there are really kind of motivated by these very abstract fundamental problems or the beauty of a mathematical equation, and I'm so happy people like that exist. But it's not me. I'm more excited by tangible problems, things that we can relate to society, to human needs and problems. And so moving towards looking at the atmosphere, looking at air quality and climate, just made more sense for what I'm personally motivated by. I'm measuring the number and size of aerosol particles in the atmosphere. Aerosols are any small solid or liquid drop that's suspended in the air, so in the atmosphere that we fly through. And they can come from multiple different sources, so there could be desert dust that's blown up into the atmosphere and the little bits of sand stay there, or it could be sea spray blown up. But you can also get things like particles forming out of the gas phase to make solid or liquid drops in situ in the atmosphere. And those are the really small ones, and we're quite interested in measuring those. The reason we care about aerosols in the atmosphere is they're affecting climate, they're affecting the radiative budget, and even though they're quite a small effect in there when you compare it to things like greenhouse gases, they're one of the less well understood ones. And so the better we can start understanding these aerosols, particles, where they are, how they move around the atmosphere, how they're transformed, the smaller the uncertainties we have on our climate predictions. Also, aerosols are really important for human health, and so we want to be able to predict where we've got high concentrations of them, what they're made of, and all of the things that might be impacting health. And so it's really interesting for us to measure them, especially this whole sort of global pattern that we can capture on ATOM, and really see where that's happening and potentially why it's happening. Where the window would normally be on a plane, we have like a metal window plate, and in that we have a custom inlet that brings in air without losing or changing the particles that are present in it. And then this goes through a system of different tubes to bring it to all of the different instruments in our suite. And we need multiple instruments because aerosols can range hugely in size, from just a few nanometers in size right up to many microns. And so you have to use different techniques to measure them at different sizes.